Hi friends and welcome. In Python, there are two ways of copying values from one object to another, shallow copy and deep copy. To fully understand these techniques, we need to know what happens when a variable is declared. A equals 1. This translates to the assignment of the value 1 to a variable named A. When you perform this assignment, a variable is created and the value associated with this variable is stored in a specific location in computer memory. In computer terms, this is referred to as an object. A serves as a reference to that object. After this assignment operation, the value of A is 1. That means we can easily say print A, and the value we get from it is 1. On line 2, when we say B equals A new variable B is created, but it references the same previously created object. At this point, if we access both A and B, their values are both 1, since they both reference the same object in the computer memory. The third assignment, A equals 2, creates a new reference to a completely new object entirely. That is why the value of A is 2 and the value of B is 1, which was the first object created. Going by the same principle, but using a list in this case. In this example, A represents a list of numbers. A new object is created in the computer memory and A references this object. When we assign B equals A new reference B is created and it references the same objects. Every change made to either A or B will affect the other one. This is because A and B are referencing the same object in the computer memory. When we say A.append 4, the value of A is modified and the value of B is also modified because both of them are referencing the same object in the computer memory. When we say B.append 5, that is, we are making modification to B, A is also affected because they are referencing the same object in the computer memory. This behavior is not always what we want. The copy method provides a solution to this problem. If you want to avoid this behavior and create a separate copy of the list, you can use the copy method or other techniques such as slicing. Every object in Python has a type, a value, and a reference count. Operations such as variable assignments or passing an object to a function increase the reference count of an object. When the reference count drops to 0, the object is automatically discarded and its space becomes immediately available for use. At that point, there is no reference to such an object. We mentioned in the presentation that when you need to create a new object from another object, using the assignment operator may not produce the desired result because any changes you make to either the original list or the new list will affect the other. Let's practicalize that. Print original list, print new list. Let's execute the program and see the output. Great. For now, the original list and the new list have the same result because they are referencing the same object in the memory. So now let's make a modification to original list dot append 5. Let's run the program and see what happens. As you can see, any modification we make to any of the list will affect the other. In most cases, this is not the desired output. A workaround this, as mentioned, is to use the copy method. Let's try that. Original list.copy. Let's execute that and see what happens. Great. As you can see, the change we made to the original list does not affect the new list. That is exactly what we want. We can also make use of the slicing operator to achieve this. Original list. This syntax is going to copy all the items in the original list. Let's execute the program. Great. This method of copying object is known as shallow copy, which means that the new copy has some references to the child objects found in the original list. This will be revealed in the next example. Let's modify the original list to have some sort of children. Let's modify any child element. Original list, index of 1. Remember that index of 1 is referring to the list inside the original list. 0, 1, 2. The index of this element is 1, 0, 1. So we can make reference to it. 1 equals 9. What we are doing here is that we are assigning a new value of 9 to this element, and this element is referring to 3. In this line of code, we are modifying the original list. Remember to put a comma after each of the elements. Let's see what happens after executing the program. We have modified the original list by changing 3 to 9. which is what we have here, but the new list, which is a copy of the original list, was affected. This method of copying objects, whereby the inner objects or child objects are referenced in the copied version, is known as shallow. To really overcome this behavior, we need a deep copy, where the original and the copy are fully independent. To use deep copy, we need to import the copy module. Import copy. Then we do copy dot deep copy original list. Let's execute this program and see what happens. Great. As you can see, the original list and the new list are now fully independent. This time, the original list was cloned recursively, including all of its child objects. Any modification to the original list does not affect the copied list, as we can see from the result we have here. The sum function takes a list of numbers as input and returns the sum of the values in the list. Result equals sum, a list of numbers 1, 2, 3, 4. Point results. This is going to return the sum of all the numbers in the list. Let's execute the program. Great. The sum of the numbers in the list is 10. If the list is empty, the sum function returns 0. Let's try that out. Great. The min function, short for minimum, returns the minimum value from a list. Numbers equals 1, 2, 3, 4, 5. Minimum equals min numbers. Point minimum. This is going to return the minimum value in the list. Let's run the program. Great. The minimum value in the list is 1. If the list is empty, the minimum function raises a value error. Let's run the program again. The minimum function raised a value error. The error says minimum argument is an empty sequence. That means the sequence passed to the minimum function must not be empty. The max function, short for maximum, returns the maximum value from a list. Maximum equals max numbers. Point maximum. The maximum value in this list is 8. Let's execute the program. Great. Just like the min function, if the list is empty, the max function also raises a value error. Let's see that in action. Let's run the program. Great. This error is similar to what we encountered when using the min function. You can use the list function to create a new list from any other sequence. When you pass a sequence into the list function, it turns the sequence into a list. Each item in the original list is treated as a separate element by the list function. Let's declare a variable var name equals mango. Let's use a list function to turn this into a list. Point var name. This code will create a new list containing the individual characters of the string. Let's run the program. Great. As mentioned earlier, you can create an empty list by using the list function. Let's execute the program. This returns an empty list. In Python, both the sort method and the sorted function are used to sort lists, but they behave differently. The sort is a method, which means to use it, we need a dot notation on the original list. Sorted, on the other hand, is a function. The sort method modifies the original list and does not return a new list. The built-in sorted function takes a list or just any iterable as input and returns a sorted list. The original list remains unchanged with the sorted function. If you want to keep the original list intact and create a new sorted list, you should use the sorted function. We declared a variable called myList, which is a list of numbers. By using the sorted function, the original list is not modified. New list equals sorted. Point new list point original list my list. Let's execute the program and see the output. Great. With the help of the sorted function, we have been able to sort the list without modifying the original list. The new list is 1, 2, 3, 4, 5, which is a sorted list, while the original list is intact. This is in contrast to using the sort method, which modifies the original list in place. That's all for now. Thanks for watching and see you in the next video.